Good morning friends, welcome to the channel Discovery with Data Science. In last video we have discussed artificial neural network or simple neural network. In this video we are going to discuss advanced implementation of neural network, which is RNN and LSTM. RNN stands for recurrent neural network and LSTM stands for long and short term memory. To understand the concept of RNN and LSTM, let's consider three different scenarios. Scenario number one is very simple problem where we have sepal and petal length and width of a flower and we have to classify which kind of flower it is. So we have four features and three classifications. So our implementation is going to be very straightforward. We will be having four features in input layer and output layer will be having three classes, and in between we are having the hidden layer of three neurons, and we have two such hidden layers. Now this is the implementation of our first scenario, which is very simple, which is called ANN or artificial neural network. Now coming to the scenario number two. In scenario number two, we have a data of a share price of a certain company where we are having opening value of the share, highest value of the share, lowest value of the share, and the last value of the share, and the closing value of the share, and total trade quantity and turnover we are having as the features. Now from outside it looks exactly similar to the scenario number one, but if we will analyze this carefully, this is very different from the previous one. Let me put both data side by side so that we can compare well. As we can see, in our first scenario, my prediction was completely dependent upon the feature of a particular sample. Suppose this is my sample number one, this particular record. So my prediction will consider only this row, and based on this row only prediction it will make. But if I will come to my scenario number two data, here other features are not much relevant as far as prediction of closing price or the last price is concerned, because they are time series data, means its last value will depend what was its value in a previous timeline, and the previous will depend upon its previous timeline data. So this kind of data we call time series kind of data. Here each data is not independent as far as prediction is concerned, rather they are dependent upon the previous state of the output. But problem with neural network is that it has no inbuilt mechanism to store what was the earlier output of the certain neuron. So we can achieve this by doing very small modification in the existing neural network architecture. For the sake of simplicity, what I am going to do, I am going to remove unnecessary columns like this one, this one, this one, this one, this one, and this one. This is my requirement and my timestamp is my requirement. So I will keep only two columns. Now here is my modified data. Now what I will do in RNN, what modification I am going to do? Suppose I want to make prediction on last three data. However, last three data is very less sufficient, but for the sake of explanation I am considering only three. So suppose top three data I am considering for my analysis. Now my problem is on 28/9/2018 my share price was 233 and I want to predict what's going to be the next value, means on 29th what is going to be the share value, and I am considering last 3 historical data. So in RNN, what I am going to do, I will start from bottom. Here I am feeding my first data, which is on 26th. Let's assume this data is my current data, means T0. T0 is my current data. Then this is my T minus 1 and this is my T minus 2, and I want to predict for T1. T1 is equal to what? This is my problem. So I will start from T minus 2 and obviously it will give some output. This is my output. Now I will move to T minus 1, next data. Now in what I have done, in T minus 1 I have taken my second last data of 27/9/2018, but along with it I am also considering my output of last RNN as input to the next step. So remember, these two are not different layers, rather they are the same RNN at different timestamps. So don't confuse that they are two neurons, they are same one neuron. Consider in a two different iteration or two different loops, and again this will bring some output, and again I will repeat the same thing. Output of this data I will include in the prediction of next data. This means for the prediction of T1 I will input T0 data as well as output of T minus 1 also, and I will get some output. So from here till here is called RNN, one RNN layer, and this output is my final output. This is my final output, and remember, this is not my prediction, this is just output. Means we know in neural network we don't have only one layer, we have many other layers also. So this output will be passed on to other layers, but the story of my RNN layer has started from here and it has ended here. So this entire RNN layer we can represent in short as this block diagram, where this green color rectangular box shows the RNN layer with a activation function as 10h, and this represent the hidden layer output, means this output coming from the means input coming from the output of previous. That's why ht minus 1. This is hxt, means the input, real input, and the output is also the ht. ht means the hidden layer at the timestamp of t, input layer of the timestamp t, but the ht minus 1 means the output of previous hidden layer. This output, these outputs we are talking about, this is ht minus 2, ht minus 1, like this. This is very simple implementation of neural network. With a small modification we have added the memory functionality to it, but this memory is very short term, means it can remember only previous value. But by creating the chain, because on the output of ht minus 1 has influence of its previous input and so on. So in this way we can say, like for the final my prediction, it is having the influence of all of my previous data. This way we can say, like for this output I am having influence of this data also, because I am taking output of this data along with its input and so on. So in the final position what we are getting as output has influence of all three, but this influence is not directly, this influence is transitive way, And mathematically, this creates a problem as a vanishing gradient problem, where the gradient becomes very less. So to avoid this, what we have to do, we have to include one memory location, this which can directly store the all previous states. And to resolve this, we have solution comes as LSTM, which we are going to discuss in scenario 3. This is our scenario number 3, which is implementation of LSTM. So as we have discussed earlier, RNN didn't have long-term memory cell. So in LSTM, we have added one long-term memory cell here, represented by green color line here. And as we can see, like RNN, it is also having two inputs, xt and ht-1. And ht-1 is from the earlier loopback output, and xt is the current input. Now, coming back to the long-term memory cell, it is having three gates. One is forget gate, which is used to delete certain value from memory cell. Update gate, which is used to add certain value to memory cell. And output gate, which is used to read the value from memory cell. Let's see each gate one by one. We can see here output from this sigmoid function is getting multiplied to the existing long-term memory cell, and we know value of sigmoid function varies in between 0 to 1. This means if we will multiply any value which is less than 1, then what we get is a fraction of it. This means after this multiplication, what we get is the fraction of long-term memory. Means we can decide here how much of past data, how much influence of past data should be diluted. Means if we want to retain 75% of previous data, that is possible here. 90% of previous data, that is also possible here. That is based on this sigmoid function. This sigmoid function is deciding what amount of or what percentage of old data should remain. Now, similarly, update gate, you can see this is a tan h function which is taking input from ht-1 and xt and then applying tan h transformation here, and again this sigmoid function is getting multiplied here, which means what is going away from here is the fraction of tan h function. Here we can see it is addition, but in earlier forget gate it was multiplication. That's why at the end of forget gate we got the fraction of memory, but here it is an addition mode, which means we are adding certain value to long-term memory cell. Now coming to output gate, here we are reading data from long-term memory cell and then applying tan h transformation. Now before sending this value to output, we are again multiplying this sigmoid function here. Means fraction of it we are sending as an output for the next stage, and here ht represents the output of this long and short term memories. In this way, long and short term memory, it maintains short term memory also as well as long term memory also, and we have three gates to control data flow to it. So this is all about LSTM. For simple time series problem, RNN can be used despite its gradient descent problem, as long as it gives you output. But for complex data patterns, it really gets difficult to train RNN. Then LSTM can be used as a substitute to this. It is having the quality of RNN also, as it is having loopback input as well as current input, as well as it is holding the long-term memory cell also. So if you have to choose in between RNN and LSTM, so RNN can be used in a simple data patterns, but for complex data patterns it becomes really challenging to train RNN due to gradient descent problem. By adding long-term memory to LSTM, we have removed the gradient descent problem here. But this architecture is little bit complex with comparison to RNN. That's why places where RNN cannot be trained on, there we can use LSTM as a substitute. So as long as it gives you good output, RNN can be used. But for complex data pattern, we can shift to LSTM as its substitute, and it works well. I hope this video has helped you to understand the topic. Thanks for watching this video. Have a nice day. Thank you.